Hello everyone, welcome to our lesson. Today we are going to talk about pressure. Pressure is the chapter of grade 9, chapter 4. So as you know, the pressure is a very long topic, but in this video we will talk about the solid pressure. Solid pressure. In this video, which content we have, what we are going to study. Let's see the titles, then we continue. First of all, we will talk about what is pressure. We will define the pressure. Then we will find out the unit of the pressure. Then we will talk about the formula of the pressure. What is formula? Which formula is used? Or especially for the numerical problems. And we talk about the solid pressure. How pressure is produced by the solids, solid objects. Then at the end, then we go and discuss about the examples. Okay, we have several examples. So what are the examples for pressure in our daily life? There are actually so many examples, but I want to mention about some of them. The first one is, for example, the nail or force between the wall and the nail was concentrated into the very small area on the sharp tip of the nail. So you see here I have a hammer and I beat let's say in this example the guy is beating what? The nail, and the nail is now taking distance in the block. See, this is the block, let's say wooden block. Okay, and the nail is, you see this much distance is covered by the nail. In the second example you see, however, the bowling pin, the area touched the wall was large and therefore the force was much less concentrated. So you see we have a bowling, isn't it? We have a bowling pin. This is the area of the bowling pin touching to the, let's say, wooden block or surface. So the same hammer, same guy, and the force is acting on the surface of the nail, okay, and on this part of the bowling pin. But actually we see that distance, the bowling pin has not covered any distance, okay, in the wooden block. But here you have seen that the same guy, same force is acting, hammering, and the pin has covered a lot of distance. So what is between both of them? Difference between both of them is what? You see this surface area. This is not sharp, isn't it? It has a very large area, which is touching to the block. And here the nail has a very small area. Nail has a very small area. Okay. So what is difference between them? Same amount of force. Let's say we are applying 10 Newton force by the hammer, 10 Newton force by the hammer, and a 10 Newton force by this as well hammer. So but the nail is covering distance, getting distance, covering distance in the block, but here the bowling pin doesn't cover any distance in the block. So what is difference? Because difference is the pin has a very small area, okay, the nail has a very small area, but the bowling has a very large area, okay. So here what is difference? This is the effect of the force is here on the unit area is more but here effect of the force is on the unit area is very less. So let's continue. Next example. What is next example in our daily life which we are using? So what we use, the area of the edge of knife blade is extremely small. This creates a pressure high enough for the blade to cut through a material. So you see this end of the, you see the blade is very sharp, isn't it? Why it is sharp? Because when we applying force on it, we wanted that it should cut, isn't it? Any object, let's say any object, we want to cut it. So that's why the one end of the blade is kept very sharp. Why it's kept sharp? Because when a force is acting on it, then we want that it should cut, isn't it? So we are applying a force and we want to cut the object. Okay. So when we want to apply, we actually want to apply by a small force and cut the object, isn't it? We are trying to apply a very small force to cut the object. So, but it is kept very sharp to produce more pressure. It is kept very sharp. The knife, this part of the blade is kept very sharp to create very high pressure to cut the materials. And another example in the daily life, we can say that you see a person make deeper marks while walking on the soft ground in sharp heeled shoes than when it is flat shoes. You see here, this small area is a surface area which is touching to the ground is very small, isn't it? So you suppose that the same person is wearing two different shoes. Okay, so the force, actually the amount of force is produced is same, because same person, which is equal to the weight of the object. Okay, same force is acting on it, on the surface area. And here's again the same person is applying a force on the surface. So the person is same. Okay, but here when you see that when the person is pressing on the ground, and we see that this if she or he going to use this one, then we can see that this shoes is covering distance in the surface. Okay, so it held the surface. But what about this shoes? This shoe is remaining on the surface of on the surface. It doesn't go into the, let's say, soil or ground. Okay, so what make difference? So here there is a lot of pressure is produced. That's why this kind of shoes, they skate cover distance in the ground. But here it's remain on the surface of the ground. It doesn't take distance in the ground. Why? Because there is very less force is pressure is produced. So here pressure is less and here pressure is high. Pressure is high. But as you see here, the weight of the body, is same. Let's say 1,100 or 1,000 Newton, and here 1,000 Newton. 1,000 Newton. So then what makes difference? So if the forces acting on the ground is same, but the here pressure is less and but here pressure is more. So what make difference? Difference is produced by the surface area. So you see here the shoes surface area which is touching the ground is very small, but here the surface area of shoes which is touching the ground is high, big, isn't it? Very large surface area. So because of this surface area difference, here pressure is more produced, here pressure is less produced. So we can say the effect of the force on this area is very high, effect of this force on this area is very less. Same force, more less effect, same force, more effect. Why? Because the here surface area of the shoes touching to the ground is different. So you see that surface area touching to the object is high and more large, so that's why the low pressure is produced, and here high pressure is produced. Why? Because surface area is very small if we compare to this one. Okay, so then we can say that pressure is, if force is same, if we do not change the force constant, then we can say that pressure and the force, pressure and area, they are inversely proportional. Okay, inversely proportional to each other. So what is meaning of that? If the surface area of the object is increased, then pressure produced is decreasing. Okay, if surface area is decreased, then pressure produced on the object on the surface is increases. So this is relationship we can say between the pressure and area. Of course, if we keep this is for the if F is constant, if we keep F is constant. Okay, then secondly, if we can say that if area is constant, so you keep the area constant. So what is relationship between the force and pressure? Of course, when you increase the pressure, so force, then pressure also increases. When you decrease the force, pressure also decreases. Okay, so then we can say that pressure produced by the force on the surface is directly proportional to the force acting on it. Okay, pressure is produced by the force is directly proportional to the force acting on. Then let's discuss about what is after these all explanations. We can say that when a force is applied on a given area, pressure is exerted on the surface. So this is the area, okay. So then we can say that this area, force is acting on the surface area and the pressure is exerted. So then we can say that pressure is defined as the force normally perpendicularly per unit area. This is the definition of the force. So pressure, what is pressure? Pressure is the amount of the force acting on the unit area. What is meaning of perpendicularly? Perpendicularly means the angle between the area and force should be 90. Okay, and this is perpendicularly. So here also you see that it is perpendicular to the area. Okay, so pressure is represented by the P, and from the definition what we can say, force acting normally per unit area. So that's why we can say that pressure formula is force over area. Pressure is equal to force over area. You see, so this is force we are applying on the surface area. This is area, so which is equal to this area, same area here. Okay, because an area of object here doesn't change. So then we can say that pressure is equal to force over area. So I am applying a force on the wall, on this surface. So the surface area is this much, okay, square. So force over area is. So SI unit of the force is Newton per meter square. Why? Because SI unit of Newton force is Newton, and SI unit of area is meter square. So you divide, which is equal to Newton per meter square. Okay. So SI unit of the pressure is also called Pascal. So Pascal is what? 1 Newton meter square, or Pascal is also called pressure unit. So 1 Newton meter square is equal to 1 Pascal. 1 Newton meter square is equal to 1 Pascal. Okay. And the other SI unit for the other units are used for the pressure is millimeter mercury, centimeter mercury, and atmospheric pressure. Atmospheric pressure is represented by ATM. So I want to tell you about what is meaning of, for example, pressure is, we said pressure is 1 Newton meter square is equal to 1 Pascal. What is the meaning of this? Meaning of this one, it means that if for example we have surface area, and the force is acting on it. Okay, so meaning of 1 Newton 1 Newton meter square means that on the unit area there is 1 Newton force is acting on it. Okay, so let's suppose that this is 1 meter square area. It means that 1 Newton force is acting on it. Okay, so for example, if pressure is, let's say pressure is, let's say 2 Newton per second, 2 Newton per meter square. Got it? So it means that I have a surface area and there is a force acting on it. Okay, and the area is this much, let's say. Got it? So meaning of this one is, so 2 Newton per meter square. So 2 Newton per meter square. So it means that there is 2 Newton force acting on a unit area. Okay. Okay. So let's say this is 1 meter square. This is 2 Newton. Got it? So per each meter square is there is 2 Newton force acting on it. Let me give you another example. Let's say 20 Newton per meter square. So it means that if pressure is 20 Newton per meter square, it means that per unit area 1 meter square there is 20 Newton force acting on it. Okay. Pressure of the solids. Let's talk about the pressure of the solids. What is that? Pressure of the solid, pressure is the force per unit area. So what we studied, so pressure is equal to force over area. Okay. This means that the pressure of a solid object exerts on another solid surface is its weight in newtons divided by area area in square meters. So what is meaning of this? For example, I have this object. So this is a solid object, isn't it? This is cylinder, let's say solid, and I have another object. This one is also surface. This is also solid. So this solid object cylinder is on a plane, isn't it? It's standing on the plane. It is placed on a plane. So this solid is producing a pressure on the next one, on this one. Okay. So the pressure here produced by the solid on the another solid is equal to its weight over surface area, which is touching to the next solid. For example, so you see, for example, I have another object here. I have an object here. Let's say this is the cube. I have a cube here. Okay. So you see, if this cube is, let's say, on a table, so this cube is producing pressure on the surface of the table. Why? Because there is a force acting on the table. Which force? Which kind of force is it? Gravity force, which is equal to the weight of the object. Got it? So because of its weight, now this cube is applying a force on the surface of the table. Okay, so that is why it's producing a pressure. So this object is also producing a pressure on the surface. Okay, so this pressure is produced because of its weight. Due to its weight, it's producing a pressure on the surface. So this pressure is equal to, the main formula of the pressure is equal to force over area. Okay, but here, which kind of force is that? Gravitational force. Okay, means weight of the object, isn't it? Which we call weight of the object. So weight over area. Then the weight is equal to, if you remember, mg, mass of the object, multiplied by gravitational field strength. Okay, then instead of the weight w, we are going to write mg over area. So this is the formula which is used for the solid's pressure. Okay, so any solid placed on any surface, so it is going to apply a pressure, and this pressure is equal to the mg, weight of the object, over the surface area touching to the ground area or next surface. Okay, let's do some example together now. What is first example? A boy mass of 42 kilogram stands upright on a floor. So what is the meaning of question? We have a guy standing on the surface. He has shoes. Okay. If the area of the contact of his shoes is 20 centimeter cube, the square. So the total area, let's say A1 and let's say A2. Okay, so total is equal to A2 plus A1, so equal to 21 centimeter square. Determine the average pressure exerted on the floor. So this guy is producing a pressure, applying a force because of his weight. That's why on the surface of the ground there is pressure produced. Okay, so what is given in the question? So mass of the object is 42 kilogram. Okay, and the surface area is given 210 centimeter square. Okay, then total weight is so 2 centimeter square we have to convert to the meter square. So you will divide 200 by 1000. Okay, to convert to the meter square. Okay, so which is equal to 0.021 meter square. Okay, centimeter square divided by 1000. So you will find 10,000, sorry, 10,000. So you will find the area, meter square. So that's why we can say that 110 centimeter square is equal to the 0.021 meter square. We have to, if centimeter square is given, of course we have to change the we have to make conversion. So as we said, the weight of the object, body is producing force on the ground, okay, which is body weight, the guy weight. Okay, so what is weight? Weight is equal to mg. This is the formula. So what is m? 42 kilogram multiplied by 10. 10 is what? Gravitational field strength, okay, which is given 10. So 42 multiply 42 multiplied by 10 is equal to 420 Newton. So 420 Newton force is acting on the floor. Okay, then let's apply the formula. Pressure is equal to force over area, and next is pressure is equal to, here force is which kind of force do we have? We have gravity force, which is, we can say, weight. Okay, so weight over area. Then we write what is weight? Weight of boy is 420 Newton, and what is surface area? 0.021 meter square. So when you divide by this board, then you will see that 20,000 Pascal or Newton per meter square pressure is produced. So this guy pressure on the surface is, okay, pressure produced on the surface is 20,000 Pascal. Next example. In this example, what we have, an iron block of 660 kilogram exerts a pressure of 15 Newton per meter square on a flat surface. Determine the area of the contact between the block and the surface. So what we have here the surface. Let's say we have a surface. Okay, so here we have a block. Okay, we have a block. Okay, so this is the surface area of contact, and the block mass is 60 kilogram. And how much pressure is produced on the flat surface? Pressure produced is mentioned 15 Newton per meter square. Okay, this is the question is given. So the mass is 60 kilogram. Pressure is given 15 Newton per meter square, and the next one is, so first of all, pressure formula, as you remember, pressure is equal to force over area. So pressure is equal to, here force is weight of the object over area. So from this formula we can say that area is equal to weight over pressure. Okay, so we have just replaced the A and area and pressure. So from this formula we can say that area is equal to weight of the object over pressure. Okay, so then write area is equal to weight of the object is equal to mg. So m is 60 kilogram and g is 10, so 600 Newton is the weight of the object produced, over what is pressure, which is given 15 Newton per meter square. Okay, so the answer of this question is what? 600 Newton. Answer is, I think, will be 40, isn't it? Yeah, 40 meter per square. Yeah, so pressure is equal to force over area. So force is weight of the object, which is 600 Newton, and the area is 15 Newton per meter square. So when you divide, then you will find the 14 meter square. So it means that the area of the block touching to the surface is 40 meter square. Okay, example 3. A block of 30 centimeter long, 20 centimeter wide, and 10 centimeter thick has a mass of 750 gram. Determine the, so this is the details of the block. 30 centimeter is long, okay, so this is 30 centimeter, and 20 centimeter wide and 10 centimeter thick, has a mass of 750 gram mass. Determine for this question maximum pressure that can be exerted by the brick on the flat surface, maximum pressure, and minimum pressure that can be exerted by the brick on the flat surface. So take G is 10 Newton per kilogram. Okay, so on which area we put the object, so we can get maximum pressure, and on which area we keep object, we get minimum pressure. This is the question. So mass of this block is what? 750 gram, isn't it? So then we have to convert to the kilogram, divide by 1000. Okay, divide by 1000. 700 gram divided by 1000 is equal to 0.75 kilogram. Okay, the next step is we have to find out the weight of the object, because we have to find the force, which is weight of the object, mg. Mg is equal to 0.75, because which is mass, multiplied by gravitational field constant. Okay, 7, so 0.75 multiplied by 10 is equal to 7.5 Newton is the weight of the object. This is the maximum, or the weight we cannot change, so which is equal to the weight of the object. And let's find the area, surface area of the object. So this is the one of the surface area of the object. You see, this is, we can keep the object on the surface, okay, by using a surface area of A1, or we can keep the object by this surface on the ground. Okay, this is another surface area, which is A2, or we can keep the object on the surface by using this area. This is A3. Okay, so let's find which area is maximum and which area is minimum. Okay, so maximum area is A1. Why? Because area is equal to 30 centimeter multiplied by 20 centimeter. This is the maximum area, isn't it? So we can say that area 1 is largest, then area 2, and area 3. Okay, so what is area 1, which is maximum? Area 1, maximum area is equal to 20 multiplied by 30, isn't it? So 30 centimeter multiplied by 30 centimeter, which is equal to 600 centimeters square, and which is equal to 0.0206 meters square. So this area is equal to 0.06 meters square. Okay, and the minimum area is the A3. As you see, A3 is the minimum area. So what is A3, which is equal to 20 multiplied by 10 centimeter. So 20 centimeter multiplied by 10 centimeter, which is equal to 200 centimeter. We convert meter square, which is equal to 0.02 meter square. Okay, so maximum area is 0.06 meter square, and the minimum area is 0.02 meter square. Okay, then how about A2? A2 is equal to 30 centimeter multiplied by 10 centimeter, which is equal to 300 centimeter square, and which is equal to 0.03 centimeter meter square. Okay, so you see that the maximum area is A1 and minimum area is A2. Then let's do the pressures. So these are the what we have find out. Weight is 7.5 Newton. Maximum area is, which is A1, 0.06 meter square, and the minimum area is A3, which is equal to 0.02 meter square, and A2 is 0.03 meter square. Got it? So why we are going to find out maximum area and minimum area? So this just remember, here the force is constant. Okay, here force is constant. Force is constant. When force is constant, okay, if you remember, we said that pressure is inversely directional proportional to the force. Okay, they are inversely proportional. So then what is meaning of this? Meaning of this, when you increase the area, so pressure decreases. When you decrease the area, pressure is increasing. Okay, so then we can say that for maximum pressure, then we need minimum area. For minimum pressure, so you need maximum area. Got it? So let's see for A. Question number, first question A. Maximum pressure produced. So if maximum pressure is less than, then we have to take minimum area. Okay? Then let's go and write. So pressure is, maximum pressure is equal to weight of the object, weight of the brick or block over minimum area. Minimum area is A3, which is 0.02, and the weight of the object doesn't change, which is constant. So what is weight? 7.5 Newton. What is area? 0.02 meters square. So the pressure produced when the object is kept on the area, this area, so pressure produced is 375 Newton per meter square. Okay, so how about minimum? So you remember, for minimum pressure, then maximum area, minimum pressure and maximum area. Okay, question number B. So pressure minimum, we want that question pressure should be minimum, then weight over maximum area. Okay, then weight of the object is again constant. Which area we are going to use? A1, because A1 is maximum area. Okay, then 7.5 Newton weight of the object, and 0.06 is the maximum area. Then we will find 125 Newton per meter square. So you see here area is high but large, and but the pressure produced is less. Here area is very small if you compare with the rest of them, but the pressure is very high. Okay, so lower the area, higher the pressure. This is the key point of the equation. So relation between the pressure and area and force. So this is what we have studied at the end of this video. Let's just revise it. If area is held constant, the higher the force, the higher the pressure, and the lower the force, lower the pressure. Okay, this is what we have mentioned. The first one is for if area is constant, so force and pressure, they are directly proportional to each other. Okay, force and pressure, they are directly proportional to each other. So increase the force, increase the pressure. decreasing for decreasing pressure. Next one, if force is kept constant. So here is force is constant, and what we said, constant. So force is constant, then pressure and the area, they are inversely proportional to each other. So increasing the area, decreasing pressure, decreasing area, increasing pressure. Okay, this is the last part of the end of the topic video which we are going to we have studied. So the smaller the area, greater the pressure, and the large area, the smaller the pressure. Okay, thank you being with us. For more details, visit the website www.ncdphysicswebly.com. If you enjoy the lesson, please go and just like the video and subscribe to NCD Physics to be notified for next videos. Thank you for watching us.